And welcome back to another episode of Containers from the Couch. We have a full panel today, full screen. A couple of people living in the same house I see as well. Or it's the same background, but it's okay. No worries. Um, Welcome everybody to another episode of Containers from the Couch. Welcome to everybody that's viewing us online as well. Thank you for joining us today. We've got an interesting episode today, something about security and guard duty. And we have all three guests here today, which is Rushab, Wasiq, and Kunjan. And I'm going to ask them to introduce themselves because I'm going to probably mess up anything that I say here today. Wasiq, can you please give us an intro of who you are, what you're doing in AWS, and what you're here to talk about?
Yeah, my name is Mohammad Wasiq, but you can call me Wasiq. I'm a principal security engineer with Amazon GuardDuty currently, and my role is basically to research and develop threat detections for GuardDuty.
Awesome. Kunjan?
Hello, everyone. My name is Kunjan. I am with AWS GuardDuty as well. I'm a tech lead in the GuardDuty team, working on making it easier for customers to um, manage the resources through provide security on like newer services, primarily runtime monitoring.
Awesome. And Rushab?
Hi, this is Rishabh. I'm a senior software engineer at Amazon ECS. I work on the control plane side of things, and as we know, ECS is the container orchestrator, pretty big one, and I work on internal services to help customers onboard to newer integrations through ECS.
Awesome. And my name is Maysado Casing. I'm a developer advocate here with the ECS service team. And we do this stream on a regular basis every Thursday, once every 2 weeks. We alternate with the EKS service team as well. And today we're here to talk about security and guard duty. So for everybody, firstly, which is on the chat, please let us know, have you used guard duty before, where you're tuning in from today? And of course, if you have any questions for us, please feel free to drop them in the chat. We'll try to get to them either live on the show or through the chat as well. And if we don't get to all of them, I really apologize because we have a lot of people on. Actually, I see a lot of viewers today. So we'll try to get to all of them. But if we don't, I'm sorry. Well, if the worst comes to us, you can always ping me directly, either through Twitter or other mechanisms that you would like to find. So Wasiq, can you want to kick us off today?
Thank you, Maish. Yeah, so we'll be talking about the runtime monitoring for ECS and Fargate, GuardDuty runtime monitoring that we recently launched in reInvent 2023. So for those who do not have deep understanding of GuardDuty, I'll give a brief introduction about GuardDuty. So GuardDuty is an AWS service, is a threat detection service that uses machine learning, anomaly detection, and threat intelligence to identify threats in customers' AWS environments. It basically monitors multiple log sources. There are 3 core log sources which are enabled by default when you subscribe to GuardDuty. These core log sources are VPC flow logs, Route 53 DNS logs, CloudTrail logs. And then for past few years, we have been adding several opt-in log sources or features. The first one that we added is S3 data plane logs, which monitors the data plane activity on your S3 buckets, and it is really good for detecting threats such as somebody exfiltrating data out of your S3 buckets. The other one that we launched, the opt-in feature that we launched, was RDS monitoring. So we can also monitor your RDS database instances and detect threats like somebody doing brute force attack on your RDS instances. And in 2022, we launched EKS audit logs, which is Kubernetes audit logs monitoring for EKS clusters. And it allows us to detect threats against your Kubernetes clusters on EKS. And another feature that we launched in 2022 is malware protection or scanning. It is basically the static scanning based, and this feature involves scanning EBS volumes to detect malware. And last but not least, we launched runtime telemetry in 2023. The first incarnation of runtime telemetry was launched in March 2023, and it was only for EKS. But then in reInvent 2023, we launched it for ECS and Fargate as well. It's a agent-based solution. Basically, it involves deploying agent on the customer's EC2 instances or tasks, and then collecting runtime telemetry from there, and then using it for threat detection. So we'll be talking in detail about the runtime telemetry or runtime monitoring for ECS today.
Okay.
Okay, I'll pass to Kanjan now.
Thank you, Wasiq. So,
Want me to bring up? Yeah. Want me to bring up your screen?
yes, thank you.
Okay.
Okay, awesome. So, yeah, I'm super excited to talk about runtime monitoring, which we believe is a modest leap towards providing security for containers on a leap day. So, no better time to actually time this whole presentation. So, runtime monitoring, as Wasiq mentioned, is about getting closer to the compute, closer to the workload, monitoring the activity on the workload, and then providing more insights to the customer. So there's a security value that is attached to it, which is useful for actually knowing which of the containers are exhibiting the threat, and also then making uh, taking appropriate remediation actions against that. So makes it easier for remediation, gives the security operator more context, as well as it's real time, right? So it will be more real time as well. The the Fargate case is more interesting in this case. So if you just look at comparison between runtime monitoring for EKS, which we announced last March, compared to Fargate, so there are a few similarities and differences between the two. For example, the similarities between the runtime monitoring for across all these platforms is the agent that we built. So the agent is an eBPF agent that is uh, deployed through various mechanisms, which differ by the service types. But at the end of the day, it's the same agent with the same core capabilities, able to collect operating system events, decorate them, do some filtering aggregation, and then send them via a VPC endpoint back to the service for analysis. So that's the similarity. The other similarity is also the finding types are mostly very common between them. You'll see some differences between the various service types, but usually the findings are also very common. But that's where the similarities kind of end. Now, when you compare EKS and EC2 versus Fargate, the coverage that the visibility of the agent is on the instance level, whereas with Fargate being a serverless container, it's at the task level. So with Fargate, the agent is monitoring the actual containers that the customer provides, whereas in EKS and EC2, we monitor actual instance itself. With EKS and EC2, the coverage begins as soon as we deploy the agent at the instance level, whereas with Fargate, the tasks are immutable. So the GuardDuty is going to provision the agent on the task, and then existing tasks need to be restarted. And so we'll get into that as well when Rishabh talks about it on the ECS side. Similarly, with management as well, we will see that EKS and EC2, GuardDuty will provide the management for and the updates for these agents. The one important aspect that we believe, in addition to security value, is how a security operator will be able to manage the deployment of these agents across their organization. So what I'm showing here is a runtime monitoring uh, console for in the GuardDuty console or runtime monitoring protection plans, where a operator would potentially will, for example, in my setting, I am a delegated administrator for the org, and I have a couple of accounts. I have Rishabh's account and I have Wasiq's account here as my member accounts. And what this allows me to do from GuardDuty console is be able to apply these protection plans across my member accounts. And I can do it either by selecting the individual accounts here and applying those plans, or by going to runtime monitoring and then selecting the options here. So we have one runtime monitoring opt-in for the customer. So once you select runtime monitoring enabled, telemetry, security telemetry from agent deployed in any of the resources, GuardDuty will be accepting the telemetry, processing, and generating findings. But we have separate management configuration. So this allows GuardDuty to manage the agent on the behalf of the customer. So we have one for ECS, one for Fargate.
So I have a question, if I may. Can I ask, if you don't mind
Yes.
me interjecting for a second? I'm trying to understand what kind of the customers would use this feature, as you say, of enforcing this kind of monitoring or security on more than one account. Why would they do that?
So it simplifies. So in a typical organization, you may have more than one account. So customers who are using AWS organizations today, who are managing their accounts in their organization through AWS orgs, GuardDuty integrates with AWS org. It lets you create an delegated administrator which would be typically your security team, who would be then responsible for ensuring like all the whatever you have as your protection mechanisms get applied to your account. So it simplifies the deployment or management of security controls in your across your org.
Okay.
It also allows the uniform application of security controls, right? So you can uniformly apply the security controls across all your account and the new accounts being added to org. So
that would improve the organization's security stance. If they, in other words, it makes it compliant with all their regulation that they have and their different standards that they have within their organization. Okay.
Yes,
right.
That's right.
Perfect. Thanks.
So we exactly give that option, right? We have for each of these options that we see here, we have the ability to say what is the profile or the plan that you want to enforce for new accounts that join your org, or for what is the plan for the existing accounts, and then you can select this for the ECSN. The way you would do that is you would come to this configuration, and once you set it at the org level, you don't have to worry about new accounts and whether they're protected or not. GuardDuty will ensure that those accounts automatically get the enforced protection that they need. So when you select these settings, what actually is happening is behind the scenes, GuardDuty, when you select any of the management options, in case of Fargate, GuardDuty will take care of injecting the agent. So Fargate is interesting because it's serverless, as I mentioned. And if you look at how you would do this outside, it's not a managed solution that we are offering here, then you would have to update the task definition, go to every account, go to every task definition, update it to say that you want to include a particular security, like GuardDuty, for example, GuardDuty agent, deploy it, have the permissions for it to talk to its necessary AWS services and to send the telemetry. All that is now automated for you, not only at an account level or a task, but or a cluster level, at an org level. So that's where we believe it's makes it very convenient and very easy for the operator to actually deploy this Fargate protection into their account.
Okay. So we're already getting a couple of questions coming in from the audience, and one of them I wanted to ask myself, because I see we have EKS, we have Fargate with ECS and EC2. So the first question was, does it work with Amazon ECS on EC2 as well?
So yes, so we don't have a management aspect for EC2, but as you'll see that if I go to my console later on, the agent and the protection for ECS, EC2 exists as well today. So we monitor that. Okay. We are not deploying automatically to the EC2 instances yet. Customers have the option of deploying it through SSM, through deploying it in the Army. But short answer, yes, protection exists. The automatic deployment does not exist yet.
Okay, and the second question goes to resource utilization, because of course every container which we deploy as part of the task or as part of the every deployment, whatever it may be it on Fargate or be it on EC2, it takes up resources. So how does that allocation of those resources work?
So
in other words, how much CPU or memory are we going to get to that further down the road?
We are going to get that, but I just want to quickly say, with respect to Fargate, we have resource utilization published, how much GuardDuty uses on our documentation.
Okay.
But with respect to Fargate, depending on your task size, we control the thresholds that the GuardDuty agent would use in the task. And we will
Okay,
see some of that in the Rishabh's demo.
Awesome. So thank you everybody for your questions. Keep them coming. We'll continue to roll. Yeah.
So one last thing I want to add here is the management aspect of this. When you enable management, the VPC endpoint that is provisioned by GuardDuty also takes care of the actual cost. So GuardDuty pays for the telemetry, shipping of the telemetry from the agents to the service. So that is one important aspect I wanted to call out here as well. Okay, with that, I want to hand it over to Rishabh to show the actual changes that would be seen by ECS operator in their account.
Okay, so let's move over to you, Rishabh. You're muted, unfortunately.
Hello.
Yep.
No, yeah. I was just checking if my screen was showing up. So hello, everyone. Before we get started with GuardDuty and ECS, a quick spiel about Fargate, because we are here. Fargate with ECS is where like ECS truly shines. ECS takes away the kind of management of the containers part from the customer's plate, but with Fargate it also takes away the provisioning, patching, maintenance of all the infrastructure as well. So you get this simplified solution which is powerful at the same time. You just define your application spec, and ECS finds the capacity to run it on, manages your containers for you. And with this launch itself, which we did in reInvent 2023, you get the powerful option of having security telemetry analyzed for your container as well with the click of a few buttons, as Kunjan just showed from the GuardDuty console at an org level itself. So that's about Fargate and the principle of powerful simplicity. So, but let me start off now. So quick reminder of what we saw on Kunjan's dashboard just now. This is my account here, and you can see that runtime monitoring is enabled. And for Fargate, automated agent configuration is also enabled, which means that I have expressed my intent here to GuardDuty that you should manage the provisioning of the security agent in my tasks. And if it wasn't clear from before as well, the GuardDuty security agent is modeled as a sidecar in your Fargate tasks. So it shows up as a sidecar. It's an additional container which you don't have to define or manage. It's all taken care of for you. So on the ECS side, talking about the kind of experience we've changed there, and with this new feature, you can see that in your account settings page on the Amazon ECS console, I also am able to see here that my runtime monitoring is enabled, which is great because, as Kunjan mentioned, that a lot of organizations have a lot of accounts and there's a dedicated security team that kind of enables or disables security controls. And I, in this case, am, for example, representing a developer team in such an organization who's focused on building applications with Amazon ECS. So they also have some visibility into seeing that, yes, the ECS runtime monitoring is enabled for their account. So now let's look at our clusters. I have 2 clusters here. I'm going to be launching some tasks into them. And as we know, to launch tasks in ECS, you have to define an application spec, which is better known as a task definition. So let's look at the task definition that I've already created here. I'll go over some of the interesting bits here. One is I only have one container defined in here. As you can see in the container definitions, there's only one container. I have it's a Amazon Linux image. There's some command that will do some activity which will come in handy later. I've defined the log configuration, pretty basic stuff. And it's a Fargate task, so AWS VPC. I've defined some roles here. Where are they? Yeah, so I've defined execution role, task role, pretty basic stuff, which if you've ever used ECS, you'll know this is one of the first steps that you take in order to create a task. And what ECS will do is it will take, when you provided this task definition, it will kind of hydrate this definition into an actual task that actually performs a meaningful work for us. So now
I have one quick question before you continue. When you said the IAM roles, is there any specific permissions you need to give to the task in order to interact with GuardDuty, or does that happen in the background as part of the service?
Yeah, I was going to come to that.
Sorry.
That's a very good question. No. That's a very good question. So as you can see here, the thing to note here is that we haven't added anything GuardDuty specific in the task definition. I haven't had to tell the task definition that I need a GuardDuty sidecar or anything, which means that if you have an existing task definition, you can use the ECS and GuardDuty runtime monitoring feature. To your question for task role and execution role, an execution role is required for the integration to work because we use Amazon ECR to pull the sidecar container from. So you need to have the execution role in your task definition. And if I look at my execution roles permissions, you just need to have the Amazon ECS managed task execution role policy. So it's a managed policy that we went. It has all the necessary permissions already. So that's one thing you need.
But there's nothing GuardDuty specific that you have to add.
No,
Okay.
There's nothing GuardDuty specific. If you're already using execution roles with this managed policy, there is zero changes that you need to make to your existing task definitions or even clusters for that matter. On the ECS side, the experience has been deliberately designed to be kind of touchless of sorts. So coming back to our clusters page, now I have a task definition that I know I'm going to that I'll be able to run tasks with. So let me go to this cluster first. You can see that there's a no tag suffix here. I'll come to that later. That will become apparent in a brief while. So let me start a service. If you've ever done this before, it should be pretty straightforward. I'm going to use Fargate. I'm going to create a service. I'm going to create the task definition that I just showed you. Let's call this containers from the couch live service. I'm going to have one desired task and nothing else. I'm just going to go with the same defaults that we provide. One interesting bit here is networking, since we are using Fargate, and as an implication of that, we are using AWS VPC network mode. We have to provide a subnets. Like ECS will place the tasks from the service into one of these subnets here in your VPC. The only thing we need to ensure is that our subnets have a path to ECR over the network. And in my case, the VPC that I'm using, all the subnets have a path to the public internet through this internet gateway. So I'm fine there. That being said, it's same old as launching any service that you already have or have launched in the past. So pretty basic, added some basic parameters here, and I'm going to create a service. And remember, the automated agent management is enabled on the GuardDuty console. So I should get the sidecar in the tasks that are launched as part of this service.
Yeah.
So the service is coming up. Let's go to the service. Let's see if it has launched any tasks yet. Now we use CloudFormation to launch the service. So probably take a brief. Yeah. So as you can see, one task was launched. It's still provisioning, but we are already able to see that as part of this task, a GuardDuty agent sidecar was launched. Now this sidecar was never defined anywhere on the ECS side. We didn't have to change our task definition or define any parameters. We just launched a service as we normally do. And the automated agent management made sure that there's a GuardDuty agent that is applied and injected within this task. And this agent, once it comes up, let's see if the task, so the task is already running. You can see that the GuardDuty sidecar is also running, and this security agent is already sending telemetry to the GuardDuty backend. I want to show one more case, which is the opted out cluster. How now it will become clear why the other one said no tags. So if I see the tags on this one, it says GuardDuty managed false. This is a sort of a mechanism we provided for the ECS developer persona in this whole equation, where one security persona is responsible for ensuring that the proper security controls are applied. The ECS developers might need some time to actually gradually try this feature out and not impact their existing clusters. So you can tag your clusters with saying that I don't want the management to be true, I want it to be false. And what that will do is, remember, the automated agent management is still enabled. But if I launch a task in this cluster on Fargate, using the task definition, I'm going to just do a standalone task launch so that it's faster. Same, why I want one task, I have same VPC. I'm just going to create a task. So this task was launched here. Let's look at the task. If you look at the container details, there's only one container in here. If I go down, so no GuardDuty sidecar was injected into this. So this is one of the several controls that we provide to satisfy the requirements of like the developer persona who may need some more time to onboard onto this, and we have like a consistent experience at an org level for the security persona to manage this. So yeah, that's pretty much it. How we launch tasks in enabled with GuardDuty in ECS. One thing I do want to kind of touch a little bit upon is, if you remember the service that we launched earlier, I want to look at the deployments here. So if you are not aware, the tasks that launch as part of a service, they are modeled as part of a deployment. So I just did the first one, I created the service, so there's a deployment here. The thing to note here is, at the time of this deployment's creation, GuardDuty was enabled and all the tasks got a GuardDuty sidecar. The thing to note is, as long as this deployment lives, that will be the consistent experience you see forever. Even if you change the GuardDuty auto agent management in the GuardDuty console, this deployment is effectively immutable from now on. And there are good reasons for that. It enables better rollbacks. If you have existing services, they're not troubled. They can continue to run as they were before. Your scale up and scale downs are not impacted. So there's pretty good reasons to do that. So it's a call out that I wanted to make. And last but not the least, we also integrate seamlessly with Container Insights. If you remember, or if you may not have noticed, Container Insights is enabled on these clusters. So I get out of the metrics that I have, so here there's already a data point. So the AWS GuardDuty sidecar does is accounted for in these metrics, and you can also run like detailed CloudWatch Insights queries to see particular containers within the tasks that were launched, etc. So you get all the goodness that comes with Container Insights out of the box with it.
So that I think actually asks the question which Mohammed Banabila had with what doesn't require a specific destination log for the insight data. From what I understand, not really. It automatically is injected straight into Container Insights. You don't have to configure anything specific for the GuardDuty agent in order to appear and present all the logs here. Is that correct?
If you're talking about the metrics of the sidecar container that we injected, which is not there in the task definition, then yes, you don't need to do anything special for that additional sidecar to work with Container Insights. Container Insights internally understands that there's a new container in the task which may not be there in the task definition. It publishes telemetry for that. You can see at the GuardDuty sidecar level how much CPU it is consuming, how much memory, etc., etc. So you get all the Container Insights features for this additional container as well.
So I think we're now at 30-minute mark almost for the show. I want to just quickly stop for 1 second and recap where we are. Firstly, you're on Containers on the Couch. We're talking about the ECS, the GuardDuty integration with Amazon ECS. We have 3 wonderful guests here today. If you're watching the recording, please catch the first half an hour because it will be well worth your while. Very interesting to understand. That being said, there have been questions which I think I've asked before, and I don't know if the people are interested in answering. If you could answer, I don't know if you're going to do that now or afterwards, about resource allocation. And that is, and above and beyond the fact of resource allocation, how is the resource allocation calculated or applied for this kind of sidecar?
So I can start off by saying that if I look at my task definition here, I have, since this is a Fargate task, so there's a task level CPU and memory. I have 512 units and 1024. This is the budget the GuardDuty sidecar will use in order to operate. So the Fargate task that you have already defined, it's the same budget that's going to apply for this additional container as well. As far as how does AWS decide what resources to provide for this additional sidecar, I believe Kunjan can probably better answer how that logic works. But what I can show is that you're able to see that within the ECS console here, how much CPU or memory at the container level AWS applied for that additional sidecar. So in this case, there was no limit applied on the CPU, but there's a 125 MB limit applied at the container level for this additional sidecar. So Kunjan, do you want to talk about how we decide these values?
So yeah, we have a table published for, depending on task size, how much we believe is the required GuardDuty container memory, max memory usage. And we set a max number there. So your task, but whether that's how we provision it. And then there is nothing on the CPU. And then on memory, that's enforces a hard limit on the container itself. So whether there is no automatic resizing of the task that is happening. So it is advisable to look at the usage, how close you are, how much headroom do you have on your tasks to see if the GuardDuty container can be accommodated using, I guess, container insights as one of the mechanisms, and then adjust the task size if required. So we do not automatically adjust because that has other implications as well. And we have a published table on how we allocate those resources. We allocate memory for a given task size that I can point to.
Okay. So Sam had a follow-up question. That means we need additional allocation, which we need to take into account for this container. So for example, if my task I know uses 100% of 1 gigabyte
Yes.
of memory allocation, and you'll need to add a bit more
Correct.
to cover that extra piece for the GuardDuty agent as well, which is
That is right. Yes.
Okay, perfect.
Yeah, and that's where container insights becomes useful. You can see how it's performing and how much headroom you have, and then you can resize accordingly.
Perfect. There was one other question which I jumped across, and I think we'll touch on this in the end about cost, how this is done.
Costing?
The pricing of these things. Yeah, because,
Yeah, we can come back to
it. We'll come to that back later. Okay, so RS Setakar, I apologize. I'm not going to answer. We're going to get to that question later on. And the question is this an essential container, or it's not visible as part of your task definition? It's something which is managed as part of the integration. Is that correct?
So it is
Yes,
visible, but it's not essential. So if a GuardDuty container cannot be downloaded, or if it fails afterwards, let's say it runs out of memory, or the memory allocated is not enough, or encounters any issues, will not impact your task. So
Okay.
the task continues to run irrespective of what the injected sidecar does. There is, when I show the coverage console, you will see that the operator gets an indication of what tasks are covered, what tasks are not covered because of the agent status, but there is no impact to the task itself.
Okay, perfect.
I think we should have Wasiq show because I think that's going to be the interesting bits as well.
Yeah, I was already ended up my demo, so I was going to hand it over to Wasiq. Thank you, everyone.
I don't know if do you want to share your screen? Yep, here we go.
Yeah, thank you, Rishabh. So I'm going to be briefly talking about the findings, what type of findings, and what are the details you are going to get in those findings. So currently, when it comes to runtime monitoring, we have 31 public findings that you can always see and read about on GuardDuty's public documentation. And we will be launching several more this year. We have been working on launching several more this year. Now, the findings can be divided into two broad categories. The first one is the threat intel based or IOC based findings. So these are the findings which are triggered whenever a process inside your task tries to reach out to a known bad IP address or known bad domain names. It's very similar to our EC2 findings if you are already aware of them. The second broad category is the runtime activity based findings. So they are based on detection of suspicious runtime activity. For example, a process inside a container trying to mount a sensitive host level file system into the container. So that's one of the findings, for example. So I'll start by one of the findings here, which is fileless execution. It uses a process execution event collected by the agent. And it basically identifies if the execution is being done through the memory, meaning the binary is being read from the memory. It's not being read from a regular file or the file system. And it's a common technique, evasion technique used by malware, right? So you will have lots of common information that you also see in other types of GuardDuty findings. For example, in this overview section, you'll see count, severity, and so on. And then you have resource section in all GuardDuty findings. In this case, because the resource is a task, the resource type is ECS cluster. You also get ECS cluster details, and you also get task details. So all the task details, including the task definition, are. And you also get the details about the container which triggered this finding. In addition, we also give you lower level details, which are process level detail. For example, the name of the process, the executable path of the process, the ID of the process, and so on. Right. So in this case, and we also give you the SHA-256 hash of the binary. In this case, this is empty because this is a process which resides inside a memory. The binary resides inside a memory. So it's not a regular file. In addition, we also give you the lineage of the process. So which includes the grandparents and parents of the process. So in this case, you have 2 levels of lineage here. All right. Sorry for that. Okay. Yeah, I think that's it from my side. And I'll be passing control to Kanjan to talk about coverage and other aspects.
Thank you, Wasiq. Very interesting to see the findings there. So similar to how we let the operators, the org, delegated administrator for the account, for the org, configure coverage, they also have visibility into the actual status of the coverage. So in the coverage console, we show which of your clusters. So we show EKS, ECS, and EC2 hosts. For example, in this particular case, I have one EKS cluster. I have the ECS cluster that we were just using in the demo. And we see that one of the opted out clusters that ran a task that Rishabh launched, which did not have GuardDuty container, is marked as unhealthy, because this gives the security administrator or the operator the visibility that, oh, I actually a task was launched and it did not have GuardDuty container. And it also tells you which particular task definition was the one that actually. So yes, if we allow these ECS operator or the account administrators to like opt out if the account level setting is turned on, but then there is also the visibility angle of it where the security personnel can then figure out if this is an actual issue or not. And so that's one of the things we cover in the coverage. The other bits in the coverage, there was a question about EC2, ECS EC2. So I do have on my cluster, for example, uh, two hosts, two EC2 instances that have installed the agent using using the SSM association to actually push the agent, and they are reporting, and so they are monitored as well. And you can see that their cluster type is ECS, and then the agent version for them. When we are calculating the health of the actual cluster, so that includes the health of the individual tasks as well as the EC2 instances, the ECS EC2 instances that are part of the cluster. The tasks are ephemeral, so the task can come and go pretty quickly, and there could be a lot of them. So there is a time window that is used as an indicator of we notify if there are tasks that are still running and unhealthy, or if the tasks that have exited in the last some time that are unhealthy. So you may see that your clusters it's not, because once if a task gets launched once and becomes unhealthy, there is no way for it to get to healthy. So there is some time window thing that you will have to get to here. That's pretty much it on the coverage console. We continue to enhance the the how we report issues to make it easier for customers to like self-serve and get to the root cause of why there is something is unhealthy. But yeah, I think that's pretty much it. There is another way of getting the coverage notifications, which is through Event Bridge. So you don't have to come to the console to see what the status of your deployment is. You can there are Event Bridge notifications that are published on each of these resources. So you can use those to actually get alerted when the coverage changes as well.
And I just want to, of course, iterate that and make sure that everybody understands. This is a monitoring and alerting tool. In other words, you can get the insight of what is happening in your cluster. It doesn't actually perform as part of the service any action on your actual instances. That's correct?
You mean
or
once?
the tasks.
Which one?
Once it's detected, for example, it's running a Bitcoin miner, it won't actually stop a task for you.
Correct. Right now, we only
you
support...
can, of course, use Event Bridge to do that for you if you would like
yes.
to hook up a chain of doing actual things, but the actual service itself is as only an alerting mechanism. It doesn't actually do any actions.
Correct. So GuardDuty findings that Wasiq can be you can send them to Security Hub or to and then you can have your custom remediation steps that you can build on top of that. That's right.
Yeah. One thing I think we missed, which I didn't understand exactly correctly, maybe Rishabh can chime in over here, is how do we use this also with ECS on EC2?
So as Kunjan mentioned earlier, that the protection for ECS on EC2 is there. The auto management part is something that is different from the Fargate experience. Kunjan did mention it in passing as well, that we have SSM, I think they're called recipes or documents, associations that you can use to kind of deploy the GuardDuty container or the agent on your EC2 instances and get the level of protection you want. Or you can actually take the binary and install it yourself as part of maybe instance startup. But with Fargate, you get auto provisioning. You don't have to worry about anything. But with EC2, the deployment experience is different.
I will still get the same insight into the level of granularity of the ECS, which task it is, which ARN, which container is running. Those will also still work, even though it's running on EC2.
Correct. So on EC2, the agent is deployed as a system to service, and then it knows the ECS endpoints to talk to do the same level of decoration, and also indicate that this finding is from a ECS cluster on a EC2 that belongs to this ECS cluster. So, and then the management part of that, where we will be able to do the auto installation and update of EC2 instances, is something we are working on and will come up in upcoming months. There was
Going
a question
back to
on
the issue
cost,
question. Exactly. And that was the question: is there a cost associated with using these capabilities?
So we have a full page on how the cost actually works for runtime monitoring. I can try to summarize it real quick. The cost is the cost is cost of monitoring. So there is no cost to sending the telemetry. The only cost that's there is when when the agent is running and reporting to the service. Those are the hours. We sum those up. Those are the hours that we actually do the metering for and billing. So it's only for the cost when the agent is monitoring the actual resource. That applies to EC2, that applies to Fargate tasks, that applies to EKS as well.
Okay.
So vCPU hours based on monitored resources.
Perfect. And we'll put a link to the pricing page, of course, later on in the show notes. When you have afterwards, you can catch it on the recording as well.
Yeah.
Is there any difference with the way that we manage the agent on ECS towards the way we're doing it on EKS?
Yes, there is a difference. On EKS, we use Kubernetes constructs, namely daemon set, as a way to manage the agent. So EKS provides add-on capability. We use GuardDuty leverages add-on, and within the add-on, the EKS, the agent is specified as a daemon set. And so that takes care of deploying the agent. So we are installing as a daemon set. So that means one instance of the agent per worker node of EKS or Kubernetes, and that has the host level visibility. Whereas in Fargate, we are installing as a sidecar, which is an additional container that we inject into the task. And then that monitors the task itself. So yes, there is a difference in how we deploy and what we actually monitor, instance versus the containers within the task itself.
And if I remember correctly, you did a previous episode on Containers from the Couch on this with EKS as well.
Wasiq and
Yeah.
yes, Wasiq did one. Yes.
So, Sam, I'm going to, if you want to, we did a deep dive specifically on this, or specifically on EKS and GuardDuty. If you want to look from Containers from the Couch for that specific episode, you should be able to get a much deeper dive specifically to questions you're asking.
There's a question on EKS on Fargate. The answer is it is
Yes.
not supported yet.
Not supported
Correct.
currently.
Yeah.
So talking about not supported, then of course you've shown us currently what we have today, and everybody of course wants to know what thoughts as the service teams had about what we're going to be supporting and enhancing these kind of things in the future. If you can share a little bit with us. Of course, no timelines. We're not going to commit to any when it's going to be ready and whatever, but what the general direction of what we're talking about.
Wasiq, you want to elaborate on the findings side? Security value?
Yeah. So we have enhancement coming in for findings and detections as well as features, right? So for example, auto management for EC2. I'll just briefly talk about the findings, right? So because like runtime monitoring is pretty diverse. I mean, you can collect lots of events from event types from the compute resources. So there is lots of potential and opportunity to expand. Last year we launched with limited capabilities with 31 findings. So it is going to grow. So we have been researching a lot on growing these capabilities more and more. So for example, we are introducing capabilities to capture and detect threats based on full command line arguments, for example. That's one thing. And then we are also investing in ML based capabilities on runtime telemetry. So the short answer is that you can expect lots of growth in terms of security value in 2024 when it comes to runtime monitoring.
Nice.
And one thing
yeah.
that we recently released to make it easier for customers was also support for shared VPC. So if your accounts are sharing a VPC, now you can still use the GuardDuty management aspect of it to deploy the agents even in that scenarios. So previously was not
That's
supported,
nice.
now it's supported. So that's one thing we commonly customers
And
ask
for the
for.
customers who don't really know what a shared VPC is the fact that you have a VPC which is managed in a different account or a different specifically in a different account, usually in this case, which is shared between multiple accounts in order to have more central control of that actual
Correct.
network path. And it's done in many bigger organizations with
Bigger
enterprise
organizations.
requirements. Yeah.
Yes.
We're coming up into the end of the show. Firstly, I want to thank our audience, firstly, for the amazing questions from Sam, from Mohammed, from who else over here? We have the names over here from RS Satakar and Lakshmi. And if I forgot anybody, I apologize. I'm just quickly going over the list of names. So thank you very much for participating here. We really appreciate your participation and thank you for joining us today. Our guests, of course, from Wasiq, from Kunjan, from Rishab, thank you very, very much. Are there any closing remarks you would like to share with the audience before we call it today?
No, we are excited to.
I think that this is the only closing remarks I would have is that this is a very flexible service, easy to use, and the kind of experience that you are getting is very, customer friendly. So I think all the customers should look into it, and the aspects of user friendliness specifically.
Yeah, +1 to that. We are looking for feedback on what are the pain points and how we can help improve better as well. So we believe this is pretty exciting for to have target protection, target runtime monitoring. So should encourage everyone to try it out.
Yep.
Yeah, and this also underlines the powerful simplicity of Fargate, that no need to worry about the underlying infrastructure, and you get you pretty touchless experience to enable all these deep integrations with other AWS services, which provide like tremendous value add for your workloads.
And if you have any thoughts, of course, you can directly reach out to me in my Twitter account over here. My username over here is on the screen. My DMs are open. You can reach out to me. And if not directly to me, if you don't use Twitter, because a lot of people, unfortunately, have decided to move over to other things, I'm going to stay there. But we also have our containers public roadmap, where you can also raise a number of issues and also suggest new features if you would like to see, which we currently don't support. If it is with integration specifically over here with GuardDuty and ECS or anything else connected to containers, the link over here is on the screen. Please feel free to give us your input, because that was what we're here for. We're here to hear from our customers, and based on the customer feedback, we continue with our features and development. Thank you very much, all three of you, for joining us today. Amazing episode, as usual. I always learn new things when I come into these streams as well, even though I do know enough kind of things, but I still always learn something new. So thank you very much for joining us, and thank you, guests, from our audience. Don't forget to hit that subscribe button and like button. If they say smash that like button on YouTube. The recording will be available, of course, on our YouTube channel straight after the show. And we'd love to have you back again next week, same time, Thursday at 12 o'clock Pacific. Everyone will be back in 2 weeks' time. We do alternating weeks, as we said here, with the EKS team. So next week will be an EKS show. Thank you very much for joining us, and everybody have a great day.
Yeah.